So last time we took a look at how we can better analyze a histogram. And going back to session 3, remember that the histogram is a way that we can graphically display a quantitative variable. But first we had to do a frequency distribution where we recoded the values into bins and then created the frequency distribution, and the graph of the frequency distribution for a quantitative variable was a histogram. And how we interpreted the histogram was with the shape, the center, and the spread. And the shape is described with whether or not the histogram is symmetric or skewed, and how many peaks it has. It could be symmetric unimodal, symmetric bimodal, or symmetric uniform, or it could be skewed left or right. And then our last session, we took a look at the center, the spread, and how to find outliers on a histogram. There was 3 ways we could measure the center of a histogram, and it was with a mean, median, or mode. Now the mode was the most frequent or the most commonly occurring value in the distribution. The mean was the average of the set of observations, where we took all the observations, added them up, and divided by the number of observations that were collected. The median is the midpoint. So that's either the middle value of an even set of data, the middle value of an odd set of data, or the average of the 2 middle values of an even set of data. And how do you know whether or not you should use the mean or the median? Because those are the 2 most common measures of center, is based on whether or not the histogram shows that the data is skewed or symmetric. If it's symmetric, we should use the mean. If it's skewed, we should use the median, because the median is more resilient to outliers. How did we measure the spread? Was with the range. The range was the difference between the maximum and the minimum value. And then the second way we measured the spread was with the interquartile range, referred to as the IQR. What does the interquartile range do? Is it gives you the range in which 50% of the middle of the data lies. How do you find the interquartile range? Is you split the data in half, and then once you have the lower half of your data, you split the lower half of the data in 2, and you do the same thing with the upper half of the data. The upper 50% of the data, you split that in 2, and then once we have those 2 values, the middle value of the lower half is called Q1. The middle value of the upper half was called Q3. We take the difference between Q3 and Q1, and that's the interquartile range. The interquartile range tells us that 50% of our data lies between those 2 values. But it also helps us to determine if there are any possible outliers. And how we determine if there's possible outliers is we take the interquartile range, multiply it by 1.5, and then once we take the interquartile range times 1.5, we'll add it to Q3, we'll subtract it away from Q1, and then that'll give us our fences. If there's anything that lies outside of our fence, to the right of the rightmost fence or to the left of the leftmost fence, then we have possible outliers. So what I wanted to do in this video is I want to take a look at some data sets from StatCrunch and talk a little bit about what we've done so far. So this is, again, back to the data set of weight perception. If you're wondering where I got that, that's from the StatCrunch data set, and then the survey on weight perception. So with the histogram, we're going to be taking a look at some quantitative variables. Let's take a look at the quantitative variable height. And let's first of all do a frequency distribution here. Height. We can compute that. So there they went ahead and they did some bins for us, and I appreciate that. Okay, so and now what we're going to do is we're going to take a look at the histogram for that. So the histogram for the height. Let's see what kind of histogram we got. All right, so how do we describe the histogram? Is first of all with the shape. So it looks like the shape is symmetric and unimodal. So unimodal symmetric. And now what? The center. Well, how do we measure the center? If it's symmetric, I probably want the mean, right? So let's go and let's see if we can get some sort of statistical summary about the height here. So the height, let's see if we can find the mean. Okay, so the average height is about 67, looks like that's in inches. Okay, and I would use that measure of center since it's symmetric, but it also gives me the median. And it doesn't give me the mode, but I think that I can get it if I need to. What else does it give me? Does it give me the range? Yep, it gives me the range there. It does not give me the interquartile range. However, if I take Q1 and Q3 and subtract it, I can find the interquartile range pretty easily. 70 minus 64, that's going to be 6. But if you explicitly want the interquartile range, you can edit this and ask it for the interquartile range over here in statistics. Scroll down. You can ask it to give you the interquartile range. Here's interquartile range. Probably should have kept the other stuff too, but maybe I will do that now. Go back and edit. I want all of this, and I'm going to hit the shift button. All of this down to Q3, shift button Q3, and I want the IQR, so shift button. I threw in the sum there, but that's okay. The sum's not going to hurt me. And then I will calculate it. There it is. It gives me the interquartile range. It gives me the range. It gives me the mean, the median, all that good stuff. Okay. Let's see. So now what? Now let's see if we can determine if there's any outliers or not. So what we're going to have to do is we're going to take the IQR times 1.5. So let's take the IQR. IQR is, we found out to be 6. 6 times 1.5 gives me 9. So we will add 9 to Q3. So 79. Okay, so I will maybe just make a note of that, 79. It's going to be my upper fence. 79. And then my lower fence. Remember, 1.5 times the IQR, that was 9. So I got to take my Q1 and subtract 9 from it. So 64 minus 9 is 55. 55. So if there's anything above 79, it's a possible outlier. Anything below 55, a possible outlier. So this was for the variable height. Okay. So let's see if somehow this StatCrunch can sort our height, and we will go ascending. That's fine. We'll compute it. Okay, so what are possible outliers? We got a couple of outliers here. Anything below 55, it looks like we have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outliers on the bottom end. You can kind of see that maybe that's it right there. And then let's see on the high end if there's any possible outliers. Move all this here. Any possible outliers on the high end. So that is anything above a 79. So let's go drag that all the way down. Anything above a 79, yep, we got a couple here. Okay. And There, it's got a couple of possible outliers there. So I guess the question is, what should we do with outliers? Okay, well, what we should do with outliers is if the outliers have been collected due to some sort of natural process, either physical or biological process, and I would think height would fall into that definitely, then we should essentially keep the outliers. Because that just means that we have some individuals that are taller or shorter than 1.5 times the IQR. However, we need to be sure that there is no mistake that's made. So if somebody is 1,000 inches tall, I would say that that's probably a typo and we need to remove it. Or if it can be determined that it was collected in some other way, then we should probably remove the outliers. So I think in this case, because our outliers were due to natural processes, I'm just going to keep those outliers in my data set and call it good. Let's go back to the IQR. I believe the IQR was somewhere around here. Let's go. Yeah, here we have the IQR 6. Now remember where the IQR came from. The IQR came from Q1 and Q3, the difference between those two, Q3 minus Q1. So what does the IQR tell us? Is it tells us that 50% of our data is between, in this case, height. 50% of our individuals are between the height 64 inches and 70 inches. Half of our data is between those two heights. And the IQR just indicates the difference between those two heights. So here pretty soon we will get a visual representation of what they call the 5-number summary, and that'll give us a good visualization of some of the concepts represented here in this video.